The Epstein drive is a hybrid fusion plasma ion drive. There is a primary touch drive which accelerates the craft to the desired rendezvous speed, and a secondary hard drive which provides continuous acceleration so as to simulate gravitation force. Ships with Epstein drives, as with all astronautical ships, also have maneuvering thrusters. First, we start with the fuel. The Epstein drive utilizes a solid crystalline fuel with a 99% compactness, making it close in nature to water than solid. The solid fuel is comprised of 90% fissional material and 10% fissional material in a mixture engineered to keep radiation levels safe. The first stage reactor is electricity. The entire ship is powered by thermoelectricity. All its systems are computerized and electronic. Most mechanical systems are driven by electric motors or electric servos. Pneumatic and hydraulic systems within the vehicle are also powered by electric pumps or indirectly by thermal energy. The primary role for heat on board the ship is to keep the vehicle at a safe temperature for life to continue to function. The thermal voltage cells directly convert heat into usable electricity. Pneumatics and hydrologic heat pumps also transport and distribute kinetic heat energy throughout the ship. Harmful ionizing radiation is kept contained. The first stage reactors produce operating level of power so that the ship can be turned on. These in nature energy power the system that produce the energy which powers the second stage reactor. The second stage reactor utilizes energy from the first stage reactor to convert the solid fuel into a fission gas, powered primarily by natural fission. The solid material is inert and stable, emitting little to no radiation. This stability is controlled by layers. Utilizing electricity and light layers of the material can be destabilized into its radioactive isotopes and isotopies and its fissionable material. During this stage, the inert gas for the plasma is created and the radioactive decay of the heavy radioactive material are unstable and ionizing. At this stage, there is a radioactive gas ready to be utilized as a source of fuel. The gas flow is pumped from the solid fuel chamber through fuel line into the third stage reactor. The third stage reactor. The radioactive isotopes carried within the gaseous emits high levels of radiation, exciting the gas. As the gas flows through the fuel line, outside the housing there are gamma cells designed to function as rectify and amplify the energy of the first stage reactor. This process brings the plasma containment field online, which compresses the gas, causing it to become hot and radioactive. The alpha and the beta radiation is contained by the chemical composition of the gas. The gamma reaction is absorbed by the gamma cells and utilized to transform electricity, powering the electromagnetic containment field. The hot radioactive gas flow into the plasma reactors. The fourth stage reactor, which is the stellar Crucible chamber. The plasma reactor emulates the condition of the sun but is much smaller. Its function is to produce kinetic thrust. It does this by squeezing the hot radioactive plasma into layers or shells. The heavier elements naturally move toward the center and the lighter elements move outwards toward the surface closer to the inner chamber. At this point, the plasma is a baby star. In essence, it is a thermonuclear explosion contained inside a magnetic bubble, fueled by radioactive decay. and the continuous inflow of hot gaseous. But at this stage, while the gas displays the quality of a plasma, it is not the correct composition to qualify as a plasma drive. The fifth stage reactor, ionizing reactor. From the reactor into the stellar crucible chamber, hot non-radioactive gases flow inward and are compressed from the stellar crucible chamber. The compressed hot gases flow inward into the ionizing reactor. The ionizing reactor strips away the electrons from the hot plasma, leaving only a soup of hot atomic nuclei comprised of gaseous. None of the heavy radioactive material make it into the ionizing reactor. The mixture of hot, positively charged ions rapidly expands, but is further compressed using electromagnetic fields. 60% of the gaseous compressed within the ionizing reactor will directly power the primary torch drive. The sixth stage reactor. Ion grid. As the hot gas flows through the ionizing reactor and is compressed by magnetic containment field, it makes its way through the throat where it is primarily positively charged ion of hot gaseous atoms. These gases become accelerated toward the exhaust chamber of the rocket drive, propelling the vehicle forward. Thrust is controlled by throttling throat or by controlling how ionized the plasma is as it leaves the craft. The seventh stage reactor, Neutrino. The standard design for the Epstein drive is for the inner chamber of the rocker to be a touch drive with a continuous burn and the outer chamber of the rocket to be a continuous hazard drive. This is achieved simply through the use of free neutron decay. To separate the neutrons from the protons, an electrical current is passed through the ionizing gas. This causes it to become inert, but in the process, the gas heats up and the excessive electrons cause it to ionize once again, changing its polarity from positive to negative. After neutron decay is detected, the throat of the efficiency drive is opened and negative charge plasma is ejected with continuous acceleration powered by neutron decay.